Hello everybody, welcome back. This is lesson 6 in our unit 10. Today's topic is what is pH. The best way to go about this lesson is to watch this video while also working on the note sheet that follows along with it. It doesn't look like there's anything that is due for homework tonight. Just make sure that you are following the schedule, because the day that this is made is not the day that you're watching it, and between now and then things do change. So the calendar is up to date with all of your due dates. So just before we begin, a quick anecdote on acid rain. So acids, that's part of this unit, that's pH. And if we look at the Taj Mahal, it's a giant building that is in India, and it is made of marble, which is calcium carbonate. And so when it was first made, it was very, very shiny, very white. And then because of the chemical composition of the marble and the way it reacts with the rain, it actually gets damaged over time and the color changes. Same thing with the Statue of Liberty. And when we get to our unit, which is following this, whenever we get to the redox, we'll explain this in more detail. But when the Statue of Liberty came to us as a gift, it was a very shiny copper, kind of like a brand new penny. But over time, and even now, you think about it, oh, you're like, it's green. Well, duh. It wasn't originally green. And what happened is that it was oxidized, and that word we'll get to next unit, but a lot of it's affected because of acid rain and stuff like that. So today, we're going to talk about the pH scale. So if we're talking about acids, bases, and acidic, basic, and neutral solutions, we have to talk about what makes them acidic, basic, or neutral. So when we first started talking about this unit, we had said there were two theories. Arrhenius was talking about, acids give off H plus and bases give off OH minus. And then when we said that, I was like, hold on to that thought. We'll come back to it. We'll visit it. And then we focused on Bronsted-Lary, which said that acids donate H plus and bases accept. So we finished up that kind of portion of it, and we're going to go back to what Arrhenius said. So just to kind of recap, H3O plus is the same thing, essentially, as H plus. So if you are in an acidic solution, you have a lot more H3O plus or H plus than you do OH. If you are basic, that means you have more OH minus. So if greater signs and less signs confuse you, here's a quick thing. When I was little, this is how I was taught it. Think about it like an alligator mouth. And it eats the bigger side. So here you have more OH. If you're neutral, your H plus and your OH minus are equal. Okay. So when we're talking about pH, pH is used to measure the hydrogen ion concentration. So what pH stands for, it literally stands for potential hydrogen. So everything that we're talking about is the presence or lack thereof of H plus. So pH, you can calculate it as the negative log of that H plus concentration. Now, lucky for you that you don't really ever need to use that formula in this class. If you move on to AP Chem or Chem in college and other life things, you may need it, but not now. Acidic solutions have a pH that is less than 7. Neutral has a pH of 7. And basic solutions have a pH greater than 7. So if something has a low pH, that means it is acidic. If something has a very high pH, that means it is basic. Now, enjoy this lovely chemie. You're a 10? Yeah, on the pH scale, maybe, because you're basic. Yeah, okay. Moving forward. So if we're going to measure pH, there's a few ways we can do this. So if it tells you the hydrogen concentration is 1.0 times 10 to the negative 4, the pH is 4. So the exponent right there can give you the pH. So if it says to the negative 4, to the negative 4 is your pH. You could also put negative log of 1.0 times 10 to the negative 4, and you would still get 4. So this is why we don't really need to use the negative log equation, because you can just look at the exponent. Now if you wrote this out as a decimal, that is 0.0001. If it gives you in this form, you'd have to just convert to scientific notation, and that's where that comes from. So if you had a solution with a pH of 3, that means you have 1 times 10 to the negative 3 concentration. And written in standard form as a decimal, that is what that would look like. So when pH is decreased by 1 unit, the concentration of hydrogen ions increases by a factor of 10. So that means, here's your pH. If you're going down, remember, the more you go down, the more acidic you are. Now, because we're using logs, where it's built on a logarithmic scale, every number you jump down, you are changing it by a factor of 10. So if you have a pH of 5, 4, 3, and 2, if we go from 5 to 4, your pH changed, but 4 is 10 times more acidic than 5. Okay? If we go from 5 to 3, now we've done 2 jumps, so this is times 10 difference, and this is a 10 times difference. So 3 is 100 times more acidic than 5. If we do it, again, a different color, from 5, 1, 2, 3, to 2, you've now jumped 3 pH numbers, and 2 is 10 times 10 times 10, which is 1,000. 2 is 1,000 times more acidic than a pH of 5. So just because our pH scale, we'll get to, is from 0 to 14, because scientists didn't feel like dealing with numbers, a number in line from, I don't know, negative a million to a million. So they use the logarithmic scale, and to make the numbers a little bit easier. So here is our pH scale. Again, 7 represents a pH of 7 means you are neutral, so your H plus equals your OH minus. If you're alkaline, this also means basic. You have a pH that is bigger than 7, so your OH, let me get a different color so you can see that, your OH is bigger than your H plus. You have more OH than you do H. If you are acidic, that means you have more H than OH. Okay, so again, pH scale measures how acidic or basic something is. It ranges from 0 to 14. pH of 7 meaning you are neutral, so H plus is the same as OH minus. If you have a pH below 7, you're acidic. Again, this is a low pH, and your H plus is greater than OH minus. If you have a pH above 7, that means you are basic, and you have more OH minus in your solution. Another word for basic is alkaline, so you might see that in various things. That is what that means. Okay, so again, the pH scale is logarithmic, so each pH value below 7 is 10 times more acidic than the next highest number. So again, what this means, here's your 3, 4, 5 scale. If you go from 5 to 4, yes, that's 1 pH jump, but 4 is 10 times more acidic than 5. And if we're going from 6, that's 2 jumps, so 6 is 100 times more acidic. 4 is 100 times more acidic than a pH of 6. It also means 6 is 100 times more basic than 4. Okay, so that's kind of what I just said. If your pH is bigger than 7, you're becoming more basic. So as we go from 9 to 10, that's 1 jump. So 10 is more basic, 10 times more basic than 9. If we're going 2 jumps, so from 8, 9 to 10, 10 is 100 times more basic than 8. So even if it looks like pH doesn't change that much, it does. It changes a lot more than you actually think. So, and just go back for a second. We are going to practice this, so if you're a little bit confused now, it's okay. So here are some everyday objects. So when I'm done talking, take a second, pause the video, and see if you can determine whether or not these objects are acidic, meaning they have a pH of less than 7, they're basic, a pH of more than 7, or are neutral. If you want to, take an extra step and see if you can kind of order these increasing pH. So start with the lowest pH, the most acidic thing, and end with the most basic thing. So pause it, try it now. Well, hi, welcome back, if you paused this. So let's kind of go over this. Everything in red is an acid. So battery acid is an acid. Acid rain is an acid. Pure rain is actually a little bit acidic. Coffee, soda, stomach acid, tomato, and apple juice all are acidic objects in your house. Everything in blue is a base, so bleach, soap, drain cleaner, baking soda, milk. All of those are on the basic side of things. And then the two things in purple, blood and pure water, those are pretty much neutral. And then if you were to kind of put this on a scale, your most acidic thing is your battery acid, and it kind of moves itself down, and drain cleaner is the most basic. So this is kind of interesting to see where things lay on a pH scale. So we talk about pH. There is something that is called pOH, and pOH measures the concentration of OH minus ions. So really, 99% of the time, they only really ask or talk about pH. If you do take higher level chem classes, pOH is talked about, but it's very, very, very simple. So just like pH is the negative log of H, pOH is the negative log of the OH concentration. So if you're thinking about it, the pH scale only goes up to 14. So the amount of H plus the amount of OH has to add up to 14. So you can kind of manipulate this equation. Here's, your base. If you want to solve for pH, it's 14 minus pOH. If you want to solve for pOH, it is 14 minus pH. Okay? But again, your H plus your OH gives you 14. So if we're looking at this picture, here's your pH. So something that, we talk a lot about. If you have a very high pH, that means you have a low amount of H3O plus and a high amount of OH. As you go down, you get more and more acidic. And when you get more acidic, you get more and more H plus and less OH minus. So they're inversely related. If one goes up, the other one goes down. So acids have a very low pH and a very high pOH. Now if you take a second to think about this, acids having a low pH. If we're talking about pH as the amount of H's, it seems kind of counterintuitive. But that's why we have to think of the formula that exists. And so if you have 0.1 and 0.00001, if you write this in scientific notation, this is times 10 to the negative 1, and this is times 10 to the 1, 2, 3, 4, 5, 6, negative 6. Okay? So which number is bigger? Well, this 0.1 number is bigger. And if you were to calculate the pH of this, that would be 1. pH of this example would be 6. So that is why acids have very, very, very low pHs. Okay, so backtracking a second, bases have high pH and low pOHs. And neutral, pH equals your pOH. So we can take a second and kind of try this out. So, again, we know pH plus pOH gives you 14. That's a fact. So it says if the pH is 3.78, what is the pOH? So we know 3.78 plus, or POH, gives us 14. And if we are doing this properly, minus 3.78 to both sides, and you get your POH to be 10.22. Okay. So then the second part of the question says, based on the pH scale, is this an acid or a base? Why? So it's telling you the pH is 3.78. So we can say this is an acid because the pH is less than 7. And that's it. So let's do another one. Okay. So, the next one. What is the POH of HBr if the pH is 1.52? Based on this, is it an acid or a base? Why? So again, we know that pH plus POH gives you 14. And so right here, we just kind of manipulated the equation to solve for POH. Plug in your 1.5, which you're given. And you get your POH to be 12.48. And then we know this is an acid because it's telling you the pH, and that's really what we're focusing on, is less than 7. The next one, again, you reformatting the equation, you can get pH is 14 minus POH. Plug in your POH, which is given to you in the question. Do some lovely math. You get your pH is 3.5. Now that is an acid because that pH is, again, lower than 7. Okay. So, that's it content-wise. Let's go into some checkpoint questions. So, number 1, it says an acidic solution can have a pH of, remember, here is your scale. Here is 7, 0, 14. Anything lower than 7, you are acidic. Anything bigger than 7, you are basic. If you are 7, you are neutral. So if you're acidic, the only number lower than 7 is 3. Okay. Number 2. An aqueous solution that has a hydrogen ion concentration, so that's H+. We're talking about acid, we're talking about pH. Has a concentration of this number. Moles per liter, has a pH of, so a few ways you could do this. You could, if you wanted to, plug negative log, put this number in there. If you don't have a calculator, or if you just don't want to do that, you don't have to. Look at this exponent. That exponent means you have a pH of 8. So right off the bat, A and B are garbage. And then if 8 is bigger than 7, if you have a pH that is bigger than 7, that means you are basic. That is C. And it's not, once you think about it, it's very manageable to do. Checkpoint question number 3 says the pH of this number is. So what you have to do, again, you can do negative log of this number, 0.1, 2, 3, 4, 1, 2, 3, 4, 1. That's a lot of work. Instead, just convert this to scientific notation. 1, 2, 3, 4, 5. So you get 1 times 10 to the negative 5. And then look at your exponent. That 5 is your answer. That is it. Okay. And then the last multiple choice question. A basic solution can have a pH of, again, if you are a basic, that means you have a pH that is bigger than 7. The only number that is bigger than 7 is B, 14. Choice 4 represents an acid. B is your base. C is also an acid along with 1. Okay, so to wrap things up, here's a super duper summary chart. Let's work through this together. So if our pH is going from 6 to 8, that means we are becoming more basic. If you're becoming more basic, that means your H3O plus goes down and your OH goes up. Now, H3O plus and OH minus can never both go up or both go down. They have to do different things. Okay. And now that we figured this out, we're more basic by a factor of 100. So that's the same as 10 to the 2, because you're changing your pH by 2 numbers. Okay? So the next one, 8 to 5, you're becoming more acidic because you're becoming a lower pH. If you're becoming more acidic, that means H3O plus goes up, OH minus goes down. And you've changed 3 pH values. So that's 10 times 10 times 10, which is 1,000. So 5 is 1,000 times more acidic than a pH of 8. Moving forward, 3 to 7, your pH is going up, so you're becoming more basic. If you're becoming more basic, H3O plus goes down, OH minus goes up. You are changing 4 pH values, so that's 10 times 10 times 10 times 10, which is 10 to the 4th. And that is 10,000. So a pH of 7 is 10,000 times more basic than a pH of 3. Moving forward, going from 11 to 9, your pH is going down, so you're becoming more acidic. If you're becoming more acidic, your H3O plus goes up, OH goes down. You are changing your pH by 2 numbers, so that is a factor of 100. 14 to 13, you're becoming more basic. If you are more basic, that means H3O plus, you're becoming more acidic because your pH is decreasing. If your pH is decreasing, your H3O plus is going up, OH minus goes down, and that's 1 pH change, so that's a factor of 10. Then lastly, 4 to 8, pH goes up, you're becoming more basic. So if you're more basic, your H3O plus goes down, OH minus goes up. That is a 4 pH difference. So that's 10 to the 4, so that's 10 times 10 times 10 times 10. So that is 10,000. So what that means is that 8 is 10,000 times more basic than 4. So one thing I do want to add, I'll just go back and add it here. So this kind of helps sum up everything. So here's a number line. So I highly recommend you write this down. 0, 7, 14. If you are less than 7, you are becoming more acidic. So the farther you go down, your H plus goes up, and your OH minus goes down. If you are getting bigger, your H plus goes down, and your OH minus goes up, and you are basic. So that is it for the pH scale. Hope this was helpful. Have a wonderful day.